Hi, for this recording, I'll show you how to do part A of this question. Use the general binomial theorem to determine the first three non-zero terms of the Taylor series about x equals 0 for the function 1 plus x raised to the power half. And then write down the general term of this Taylor series and state its radius of convergence. For this, let's recall what is general binomial theorem. Okay, let's look at the PowerPoint slide for this general binomial theorem, which is you can find in David Brennan's text, page 342. It says that for alpha, a real number, 1 plus x raised to the power alpha is equal to sum of alpha n or alpha cn times x to the power n for n equals 0 to infinity, summing up. And this infinite series convergence for absolute value x less than 1, where alpha cn in this case is the usual the combinatorial symbol. I've said that you have to compute by hand. Okay, so let's go back to the question and then we work out the solution. So the question in this case is 1 plus x raised to the power half. So n is equal to half down. Okay, so based on this, we're going to do the calculation now. Let's go to the notebook here and say, so I know that 1 plus x here power n is equal to summation of n. Okay, let me write this. Is not 1 plus x power n, it's 1 plus alpha here is n alpha x power n from 0 to infinity. Now we have actually 1 plus x power half. And this infinite series converge only for x as a value less than 1. So this is equal to summation of n equal to 0 to infinity. I made a mistake here. This is alpha n. So alpha equal to half here. Half n x power n. Since we want the first three terms, so this is equal to, the first term will be half 0 x power 0 plus half 1 x power 1 plus half 2 x power 2, right? For the first three terms. And how do I calculate the first three terms? I need to find a coefficient. So what is half 0? Half 0 here is actually equal to 1 by definition. Okay, 1. You can look at the PowerPoint slide again. Okay, the PowerPoint slide where alpha 0 is equal to 1. Okay, now how about alpha n now? So half 1 is one term only that we have over 1 factorial, which is half. And half 2, you start with half, then half minus 1 over 1 times 2 is 2 factorial. So this is equal to minus 1 quarter divided by 2 is minus 1 over 8. Now for your information, just in case you were wondering where this thing come from, you have to recall this is just recite the point, just in case you're wondering how to find, say, 7c2. Right? 7c2 is what? 7c2 is just 7 times 6 times 2 point, 2 term, then 1 times 2. Okay, this is where it begins. For example, how to find 11.4? 11.4 means this means that 11c4, which is 11 times 11 minus 1 is 10, then 10 minus 1 is 9, 9 minus 1 is 8, 4 terms divided by 1, 2, 3, 4. Alright? How about say minus 3, 1, minus 3, 2, for example? Okay, so this is equal to, start with minus 3, then minus 3 minus 1 is minus 4, right? Two terms. Okay, so this is all the idea behind how to calculate alpha n, right? The idea. Okay, idea to find alpha n by hand. So I have computed the first three terms, put it in together. So 1 plus x. So 1 plus x raised to the power half is equal to 1 plus half times x minus, right? Alpha 1 is half, alpha 2 is minus 1 over 8. Okay, minus 1 over 8 x squared, the first three terms, and this converge for absolute value x less than 1. Now in the question, you also ask for a general term. General term is, based on the definition, is half n. Okay, then x power n. Okay, so what is half n? X power n means half, half minus 1, half minus 2, until, okay, half minus n minus 1. There are n factor here, then divided by n factorial x power n. Okay, so for this, we'll end the solution. Before we ask the radius of convergence, I think the question asked for radius of convergence is 1. Okay, is 1. Where the 1 come from? When the 1 come from here. Right? So let's see if we have missed anything for this question for part A. So we have found the first three non-zero terms of Taylor series about 0 for the function 1 by x power half, the general term, and state the radius of convergence. That finished the recording.